ever stopped to wonder what's really going on up there inside your own head? Well, today, we're diving into the incredible chemical orchestra that creates every single thought, mood, and impulse you've ever had. All right, let me set a scene for you. Imagine it's late, you're home by yourself, finally winding down for the night, maybe just about to fall asleep, and just like that, you are wide awake. Your heart is pounding out of your chest, your mind is racing. That instant jolt of pure fear and alertness, that's not just a feeling. Oh no, that's a chemical storm raging inside you. And it reveals a fundamental truth about who we are. And that brings us to the core idea for our entire journey today. Every single mood swing, every brilliant idea, every strange impulse that flashes through your mind, it's all driven by biology. So to really understand how you think and feel, we've got to look at the chemistry of your body, starting at the tiniest, most basic level. So, where does it all start? Well, it all begins with this tiny, incredible thing called the neuron. Your brain alone has billions of them, and they are the absolute foundation of everything you think, everything you feel, and everything you do. So, what is a neuron? You can think of them as the ultimate messengers of our nervous system. They use this brilliant combination of electricity and chemistry to pass signals to each other at unbelievable speeds. And the way they're built is actually pretty simple and elegant. Each one has three basic parts. First, you've got the dendrites. See how they're branched out? They're the listeners, always picking up messages from other cells. Then you have the soma, which is the cell body, basically its life support center. And finally, there's the axon, that long cable that acts as the talker, sending the message on its way. Okay, so here's how it works. When those dendrites, the listeners, get enough signals, it triggers what's called an action potential. This is basically a short, powerful electrical charge that just zips down the axon, like a spark flying along a fuse. It's carrying the message toward the next neuron in the chain. But here's the catch. It can't just jump across. See, the messages don't just leap directly from one cell to the next. They have to cross this incredibly tiny, microscopic space. This gap is called a synapse, and when I say tiny, I mean it. It's less than a millionth of an inch wide. So when that electrical signal hits the end of the line, it needs some help to get across this divide. And that help comes in the form of chemical messengers. And this, right here, is where the real chemistry kicks in. These messengers are called neurotransmitters. They get released from the first neuron, they float across that tiny synaptic gap, and then, click! They plug into the next neuron just like a key fitting into a lock, and that's what tells that neuron to either get excited or to calm down. And these messengers, they really only have one of two jobs. You've got your excitatory neurotransmitters, like norepinephrine. Think of them as the gas pedal. They rev the next neuron up and make it more likely to fire. And then you have the inhibitory neurotransmitters, like serotonin. They're the brakes. They tell the next neuron to just chill out, making it less likely to fire. It's this constant, delicate balance of go and stop signals. Now, as you can imagine, different neurotransmitters have very specific jobs. You've probably heard of some of these, right? Dopamine, that's huge for pleasure, learning, and movement. Serotonin helps regulate your mood and sleep, which is why low levels are often linked to depression. And acetylcholine is critical for memory. Its breakdown is a key factor in Alzheimer's. But, these lightning-fast messengers, they aren't the whole story. Okay, so we've been focused on the nervous system's rapid-fire messaging. Now I want you to zoom out with me for a second and look at the body's other major communication network, one that likes to play the long game. And that would be the endocrine system. Now, instead of neurotransmitters, this system uses hormones. These are chemical messengers that travel through your bloodstream, and they affect our moods, our growth, our metabolism, so much of what makes us tick. So, what's the big difference between these two systems? I love this analogy. The nervous system is like sending a text message. It's super fast, right? The effect is immediate, but it's also pretty short-lived. The endocrine system, on the other hand, is like sending a letter through snail mail. It's much, much slower to arrive, but the effects of its message, those hormones, they can linger for a really long time. And this whole system is made up of several key glands. You've got the adrenal glands, which pump out adrenaline for our fight or flight response. The pancreas is in there, regulating our blood sugar. And then, kind of overseeing a lot of this, is the pituitary gland. People often call it the master gland, because it's the one directing many of the other glands in the system. All right, so we have the fast text messenger and the slow postal service. How in the world do they actually work together? Well, let's go back to that scary moment, back to that banging on the door. Okay, think about it. The instant your ears heard that threat, your nervous system sent a high-speed text alert. That message shot from your brain to your pituitary gland. The pituitary gland then told your adrenal glands, time to go. And that's when the endocrine system's snail mail kicks in. Your adrenal glands release adrenaline into your bloodstream. And suddenly, your heart is pounding, you've got this huge surge of energy, and you are ready for action. It's a perfect, seamless partnership. It's really just one big, continuous feedback loop. The brain talks to the gland releases a hormone, and that hormone circles right back around and influences the brain. It's this incredible dance of electricity and chemistry that creates our entire psychological experience. And that, well, it leaves us with a pretty profound question, doesn't it? If so much of what we feel and so much of what we do is driven by this intricate, automatic, biological machinery, then who's really in the driver's seat? It's a powerful reminder of the deep, unbreakable connection between our biology and the very essence of who we are.